Okay, we've got the game plan Sharpshooter machine here, and it's kind of interesting, kind of old, 1978. Interesting sound effects and stuff. I'm going to turn it on here. So the machine's on now. Okay, so something interesting happens with this machine when you play it. I just hit the credit button. I'm going to launch the ball. Then I'm going to grab it. Notice these pop bumpers down here. They work great. I can hit these 6 targets. Great. They work great. As soon as I hit this target, they go dead. So, I know for sure I'm going to open it up and take a look. Here's the underside of the machine, and I've got the first drop target dropped. The switch looks like it's okay to me. There's a diode across each switch. I'm going to throw an ohm meter in there and see what I can find. Okay, right now I've got a meter hooked up to the diode that's across this switch, and it's reading 3.2 kiloohms. It should be open. I tried one right next to it, the same setup, and what I would expect is when I put the diode tester on and I have the polarities reversed, I'm getting resistance there that I should not get. It should be open. So I'm going to try something. I'm going to try cutting that diode and seeing what happens. Okay, so what I did, I cut the diode, and I don't know when I did it before, if you noticed, but notice the gunshot sounds on the normal targets. And now watch what happens on the one with the cut diode. No sound, but the pop bumpers. So just for grins, I shorted out that diode and tested it with the playfield up. And it would make the sound when I hit the drop target, but then it would kill the pop bumpers. So that is definitely a bad diode, and there's a reason the diode's in there. I need to look up on the schematic why it's in there. I suspect once I replace the diode, I'll be able to, when I drop the drop target, I'll get the sound and the pop bumpers will still be active. Now, interestingly, when I bought this machine, the gentleman said that the drop targets won't drop during the game. Well, I guess what's supposed to happen is they're supposed to pop back up. I'm betting it's something to do with that bad diode preventing the system from knowing it should pop the targets back up. So I'm tracing this down, and I'll look at this on the schematic. I'll show it in a video and I'll put it in. But this out hole switch has had a lot of work on it. Lots of globs of solder. It looks like it's got a new piece of plastic here instead of a switch bakelite stack. It has 2 wires coming into it, and then the diode connects across the wires. All the other switches, they don't work that way. The diode goes to an intermediate piece of metal. I think this diode is actually shorting out the circuit which controls the top target, the O, and the lane 2 roll. So, or the number 2 rollover. Okay, so tracing the schematic out, it looks like the top target is connected to that faulty O. And you can see here, there were 2 black wires added to this. Basically, they cut out this diode, and then they shorted it out. They shorted around the diode. I think it was in an attempt to try to fix the problem. So what I've done is I've taken just a yellow jumper cord with alligator clips, and I basically untwisted these wires, connected the positive end of the diode back over to this where it should connect, because the diode tested out okay. So I'll do that to see if it fixes the machine. So I want to spend a little time going through the schematic to show how I narrowed that problem down. On the Sharpshooter, this is a page from the playfield schematic, and you can see over here on the left are all of the playfield switches, and then they all connect over and they come over to this series of lines on a connector on J5. Now, if you look at the descriptions on these, there are 8 lines 0 through 7, that are inputs, and we'll get into it in a minute, inputs back to the board on in the back box. But there are more than 8 switches. So I think how they handle that is there are these strobes, 0, 1, 2, 3, and 4. So that's 5 strobes times 8 lines is 40 possible switches. Now, if you look at the schematic at pick any switch here, we'll just pick on this target O. You can see that on the left, there are a bunch of switches that are all tied together, and if you follow that back, for this particular group of switches, it's strobe 3. So strobe 3 signal is on the left here for all of these switches. And let's just again pick on target O. Let's say that switch closes. So now there's the diode, and the basic functionality of a diode, remember, is if on the anode side there's a higher voltage, then on the cathode side it's going to conduct electricity. So that means that we're talking about a 5-volt machine here. For that thing to conduct, it's got to have 5 on the right, and I'm assuming 0 on the left. So I think what happens here is the strobe is normally high. When it's time to check those switches, the strobe goes low, and any switches that are made will conduct electricity because it'll go from 0 to 5 volts. Now, it gets a little interesting here because of this matrix that's created. Remember what I said, there are a bunch of strobes and groups of strobes. Those all come together, and you can see that each set of strobe inputs connect. So we have multiple strobed inputs coming into one output line. That's how they multiplex in multiple switches into 8 lines. So for this problem, what was happening was the target O, when it closed, both lower bumpers, top and bottom, which are right next to it, wouldn't work. Whenever that switch closed, these two would not work, which was interesting, and it was kind of difficult to trace out. So what I did is I started on the schematic, worked my way back up from target O, and I followed the line around, and the first dot it connects to is loop 2, and I was having troubles with loop 2. And then it goes up to top target. Well, top target's the one that somebody had cut out the diode and shorted around it, I think, to try to fix the issue. And then the last one is out hole. So as I physically checked each of those, that's when I discovered the weirdness on the out hole. And I drew up what actually the out hole looks like. On the out hole, here's the out hole switch. And then incoming to the out hole is strobe 1, and outgoing is line 2. Strobe 1 is on a white-red line wire. I'll show you that in a second. And line 2 is yellow-gray. I'm going to move the schematic here. So let's see. Here's the out hole. You follow this line around, you can see that it's white-red. And then you follow the other end of the out hole around, and you can see it's yellow-gray. So what somebody had done is they had wired the diode in across this switch. Now, if you apply a voltage to a switch higher on the pointy end and lower here, it's effectively not going to do anything because the diode's a one-way switch. For it to conduct electricity, the anode, the fat end of the symbol, has to be a higher voltage. So, because they had the diode in backwards, it could never conduct electricity when the switch was closed and strobe pulled low. I hope that makes sense. I'm going to come back here. If this is low and this is high, it's not going to conduct electricity across that. It'll only conduct electricity if this is high and this is low. So how it got interesting, I think, is because it was backwards on the out hole, that means when the strobe was high, which means when strobe was not checking, it was a high voltage, and then you follow that high voltage back down, all the way down to target O. Well, we've got a high voltage here. Strobe pulls low to check which switches are on, but since that diode conducts, we're going to have 5 volts here and not 0. So that's going to put 5 volts on the left-hand side of the low bumpers and the right-hand side of the low bumpers, which effectively means no current flows. It does not think the switches are being activated because it's got 5 volts on either side of the switch. So hopefully that makes a little bit of sense. I believe that's accurate, but feel free to give me comments or email me and let me know if you think I'm wrong. Okay, I'm going to turn the machine on with my patch and see what happens. Alright, it's booted up. I'm going to hit the reset button. Okay, ball would normally be in play. Let's see. Yeah, pop bumpers are working. And this pop bumper is the one that died if that O was hit. Top target works. There's S, there's H, still works. Here's that first O. See if it lights up. Alright, I got noise and it lit up. Pop bumper still works. So, now all the drop targets also, when you drop them, they reset. This machine is back in business, and it was all because somebody engineered around that out hole switch incorrectly.